Let's solve part C now. So suppose that the firm exists for 2 years and replacing a worker costs a certain level. Let's call that C. At what level of this replacement is the firm indifferent between hiring a proven worker and hiring a risky worker at the beginning of the first year? Now, when we think about indifference, we know that the firm must have the same expected profit of hiring a proven worker or a risky worker, meaning that the expected profit of hiring the proven worker must be equal to the other expected profit of hiring the risky worker, and we already calculated this data. The only thing that changes in this question is that besides everything that we have over here, we will also incur a certain cost C of replacing the worker, because we know that there is a probability that the risky worker will generate us less money than the proven worker, and we are going to change that. But before doing so, let's see what's the expected profit of hiring a proven worker. We calculated that in the previous video, and we saw that it is equal to 20,000 euros. So we can write that down. It would be equal to 20,000 euros over here. So 20,000 euros must be equal to, what is the expected profit of hiring a risky worker given that there is a cost of replacement? So let's just work out the entire math to, train it once again, because that's always good. So there would be a probability of 0.3 that the worker generates us 70,000 euros in revenue, so 70k. We pay for that 40,000, so minus 40,000 euros, and this can happen for both periods. If we have the luck of hiring a worker that make us so much money for 2 periods, well, that's good. So this can happen for 2 periods. Now, what can happen with the remaining probability? With the remaining probability, the worker is worse. So with a probability of 0.7, the worker can generate us only 40,000 euros, in the first period, and we also pay for that, the 40,000 euros. Now, because it generates us only 40,000 and we can replace him, we would do so because we would get 50,000 euros from the proven worker. So we're going to replace him with a proven worker, which would give us 50,000 euros. We must pay for him the salary of 40,000, so minus 40,000 euros. And we also have to keep in mind that this would cost us a certain level. So this is the cost that we were talking about, meaning we're going to incur a cost of replacing the worker. Okay, now it's a matter of solving the math. So let's do that over here below. 20,000 equals to, let me just write it again, 20,000 equal to, from here, what do we have? Let me change colors. Yeah, a bit different. This one. No, this one. 0.3 times 70,000 minus 40,000. That's 30,000. So 30,000 euros. 0.3 times 2. That's 0.6. So we would have 0.6 times 30,000 euros plus, what do we have on the other side? So we would have 0.7 multiplied with, what's 40k minus 40k? Well, that's just 0. 50,000 minus 40,000. That's 10,000, so 10,000 minus the cost of replacement, so minus C. Now we keep solving. Let's open the brackets. We have 20,000 equals to, and we open the brackets over here, 0.6 times 30,000. That's going to be equal to 18,000. So we have 18,000 plus 0.7 times 10,000. That's 7,000. So 7,000. And 0.7 minus C becomes minus 0.7 C. And let me write that with a different color because we're looking for this cost. Minus 0.7 C. Okay, what are we left with? We have now 20,000. 20,000 equals to 18 plus 7. So that's equal to 25,000. 25,000 minus 0.7 C. So minus 0.7 multiplied with C. Let's take the C on one side and the numbers on the other side. So if we move this one, 0.7 C, to the left side, it becomes positive. So we will have over here 0.7 times C equals to 25,000 minus 20,000. We move 20,000 to the right, and it becomes 25 minus 20, that's 5,000. So 5,000 equal to 0.7 C. What would be the cost level? Well, that would be equal to 5,000 divided by 0.7, which is equal to 7,142.86 euros. At this cost level of replacement, the company would be indifferent between hiring a proven worker or a risky worker. Hope this makes sense, and we are done.